Hello everyone, I'm Shruti Kesti. I'm working as assistant professor in Department of Computer Science in ABES Engineering College, Ghaziabad. Today I'm going to discuss some example of Dijkastra algorithm. And when you are talking about the Dijkastra algorithm, this algorithm is useful to find the shortest path for single source. These are the steps to solve the particular problem. Step 1, first we initialize the source. You need to find out of what is the source node. Second, set the weight of vertex as 0 and the weight of the vertices as infinity. Set a priority queue for all the vertices on the basis of your weight. The priority queue will work as the value of the vertex. And fourth step is extract the minimum from the priority queue following the greedy algorithm concept. And step 5 is just find the adjacent node, update the weight of the adjacent node if the net weight is less than the existing weight, else retain the existing weight and update a parent node. And step 6 is update priority queue according to the accession. And step 7 is repeat step 4 to 6 until the priority queue is empty. Just take an example in how to solve the particular graph by using the Dijkastra algorithm, or you can say how to find the shortest path from one node to another. Here in this example, I'm just taking the S as a source node. So first step is initialize the weight of all the vertex as infinity and put the source node as 0. Here I'm just taking the 5 node S, T, X, Y and Z and put all the vertices as the infinity and the source node is 0. Now access the node S and update the value of your T and Y because T and Y is the adjacent of your node S. Here the cost of T is infinity. Then you can say that the cost of V is infinity and cost of U is 0 and the weight of U comma V is equals to 10. In case of Dijkastra algorithm, you need to relax the vertex which is containing the minimum value, right? So here you can see that the D of V is greater than D of U plus weight of U comma V. Here weight of 0 plus 10, yes, infinity is greater than 10. So you can relax the value of T by 10. Similarly, in case of Y, original value is infinity, but when you are going for the du plus wuv, you will get the value 5. Relax this values also as a 5. This one. And you will get these values. Now, what is the exact scenario? You can say that yes, these are the vertices S, that is T, that is Y, that is X, that is Z. Originally, this one is this one, infinity, 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 infinity. And also you need to maintain a pi matrix. What is the pi? Pi is also defining the parent of that particular vertex here. S, T, Y, X, and Z. Originally, this value is nil. When you're initializing a graph, this value is nil. Now, when you're visiting the value S, then you will get the adjacent value. Adjacent is what? T and Y. You're updating, relaxing the vertex by using the S. So the parent of T will become S. Parent of Y will become S. Because by using the value of S, you are updating, or you can say relaxing the value of T and Y, you are getting the shortest path. So from S, you will move T and Y, or you can say for reaching the T, you need to access to the S. Now, what is the minimum value? After accessing this value, this will become 5, this will become 10, and these are the infinity and 0. S is already visited, you cannot revisit that value. What is the minimum with this between these 4? 5 is the minimum, choose the greedy algorithm, choose the minimum value. Right? Then you will get this value. I think this one is here 5 and this is 10, right? This is your 5 and this is your 10. Choose the 5 vertex. Now visit all the adjacent vertices of your Y. Y is having an edge this one, and this one. Now check which one is get relaxed. When you're talking about the vertex T. Vertex T, the cost of vertex T is 10. Currently the cost is this one. But what about this one? When you are adding the value D of U is 5 plus weight is 3, you will get the 8 value. 8 is less than 10. So you can also relax this value by 8. When you're talking about the Z, Z value will get 5 plus 2, that is 7. Relax this value as 7. Again, in case of X vertex, original value is infinity, but when we are going from the vertex Y, you will get 5 plus 9, that is 14 value. It will get also relaxed. Then you will update this value by X will get 14 value, Z will get 7 value here. And again, you need to update this value, that is parent value. T's get updated by using Y. X is also get updated by using Y, and Z is also get updated by Y. Right? And then this value, you will get this value like this one. This one. This is current situation of your prop. Here, when you are talking about the current weight, S, Y, T, X, and Z, value is this 0. This is 5, this is 8, X is 14, and this is 7. You have already visited S, already visited Y. Then what is the minimum values between these three? 7. You need to visit the 7, that is Z value. Now check all the edges starting from the Z. That is this one and this one only. But 0 is already visited, or you can say S is already visited. You can only check for the relaxation of your X. Now check this one. Original weight is already 14 and Z is standing at the 7. 7 plus 6 is equals to 13. 13 is less than 14. Then you can update this value by the 13. It will get updated 13. Now this is already visited. What is the minimum value between these two? 8 and 13. 8 is the minimum value. Now again, now choose the vertex T. T, from T you are having an edge from T to X, which is containing the weight 1. Now originally cost is 13 of your vertex Vx, but when you are going from the T to X, you will have 8 plus 1, that is 9. Relax this value as 9, because 9 is less than 13, it will get relaxed. That is this one. You will get this value here. Now the last vertex is 9. No need to check for the other vertex, because in Dijkastra algorithm, when a node is already visited, you cannot go back to the vertex. So here, this will get updated and this will give you the final cost. That is what is saying that from S to T, from one node to single source. What is the meaning of the single source? Single source is fixed. You are getting the cost of from S to T, your cost is 8. From S to Y, your cost is 5. From S to X, the cost is 9. From S to Z, cost is 7. By using the Dijkastra algorithm, you are getting from single source to all other nodes what is the minimum cost. And that is this one. Let's take another example for understanding. And here we are using all the steps given in your algorithm. Here, this is the graph. Let's suppose that 0 is the source node. Put the value as what? At the 0. Here we are defining the priority queue. Priority queue is containing all the vertices. And this is the nodes which is containing what? All the nodes which parent is nil, basically. And here we are defining the weight. of each and every vertex. 0 is containing the weight 0 and other nodes are containing the value weight as an infinity. Let's move further, because in case of 0, what are the adjacent vertex? That is 1 and 7. And the cost of this one is what? 1 original cost is infinity, 7 original cost is infinity. But when you want to relax this vertex, you will go for what? 0 plus 3, that is cost is 3. 3 is less than infinity, relax this one. That is, you will get this 1, cost of 1 is 3, and here cost of 7 is 6. Because infinity is greater than this one, then it will get relaxed. And when you are relaxing a vertex, again remember you need to update the parent node. Here you are saying that the parent of 1 and 7 is 0. And 0 is get popped, or you can say deleted from the priority queue. Here you have only 8 vertex, 1, 2, 3, 4, 5, 6, 7, and 8. Now, what is the minimum value between these all? 3 is the minimum value, then go for the 1. Now, from 1, you need to check all the edges starting. That is 1 to 2 and 1 to 7. 2 and 7 both are not visited, then you can relax this value if the value is less than the cost of the 1 plus the weight of the u and v. Let's check it. Cost of 2 is infinity, and when you are going from the 1 to 5, this cost is what? 3 plus 5, that is what? 8. Obviously 8 is less than the infinity. It will get updated as an 8. And when you're talking about this 7, 7 is containing the 6 cost. Currently this is containing 6 cost, but when you're going from the 1, 1 is containing the cost 3. 3 plus 9, that is 12. 12 is greater than 6, so no need to relax this 2. This one. Here, 1 and 7 is getting this one. And now you are updated that value what? That is 2. 2 is get updated with the value of 8. And now 1 is already visited and it's get related from the priority queue also. Now which one is the minimum weight? Again greedy algorithm. 8 and 6. 6 is the minimum. Choose the 7 one and update all the vertices which are not visited and having the less value, right? In case of 7, you have 3 vertices here. 1, 8, and 6. 1 is already visited, right? You cannot go for the 1. No need. You need to check the value of 8 and 6. Currently, you are having the value as what? 6. Just check the weight of particular vertex 8 is currently infinity. When we are going from the 7 to 8, that is 6 plus 6, 12. Get the value of vertex 8 updated as 12 in place of infinity. And when you're talking about the vertex 6, you need to update this value by 6 plus 3, that is 9. This value will get updated and the parent value will also get updated. That is this one. Here you are getting the value of 8 and your 6 as this one, 9 and 12. And you have updated this value as what? 7 and 7. And 7 is also get removed from the priority queue. Next, what is the minimum value? 1 is 0 is already visited, 1 is already visited, 7 is already visited. In priority queue, which one is containing the minimum value? You can see here that what? 2 is containing the minimum value. Vertex 2 is containing the 8 value. Then choose 8 and check all the adjacent vertex which are not visited. That is 8, 5, and 3. Again, check the value. What will the cost of 3? That is 8 plus 8, that is 16. And when you're talking about the vertex 8, that is 8 plus 4, 12. 12 is already there. No need to update this value, right? And when you're talking about the 5, 5 is containing the infinity. Then 8 plus 2, that is 10. You will get this one. This one. Here, from 2, you have the value that is 5 is containing 10 value. And this 3 is containing the 16 values, which is less than the infinity. This one. Here, again, now check the priority queue. When you're talking about the priority queue, yes, 2 is get removed from the priority queue. Now check all the values of the element of priority queue which is containing the minimum value. Here 0 is visited, 1 is visited, 2 is visited, 3, 4, 5, 6 and 8 is there. 3, 4, 5, 6 and 8. 6 is containing the minimum value, that is 9. Now go for the all the vertex which get connected with the 6, that is only 5. All others are already visited, then no need to check for that value. What is the current value of 5? That is 10. When you are going from 6 to 5, 6 is containing the weight 9 and the weight is 1. Edge weight is 1 and it is equals to 10. Then no need to relax the value of 10 because 5 is already at the 10 value. Only you will change the value when the value is greater. No need to change the value when that is equal to the given value, right? When you are updating the 6 value, no changes in the weight, but 6 get removed from the priority queue. Now again, what are the rest vertices? That is 3, 4, 5 and 8. In case of 3, 4, 5 and 8, which is the minimum value? 5 is containing the minimum value. Now again, from 5, you can see that 4 is the only 5 and 4 and 3 is the vertex which is not visited till now. Then just you need to check this one. 4 is containing the infinity value. In that case, add the value 10 plus 9, that is 90. Currently, 3 is containing the weight 16. 10 plus 10, this will get 20. So 20 is greater than 60. No need to relax the value of vertex 3. This will get updated. Now, rest value is what? Now in priority queue, we have only 3 vertices, that is 3, 4 and 8. 3 is containing the weight 16. 4 is containing the 19 and 8 is containing the 12. Now, which is the minimum? 8 is the minimum value. Then choose this one also. 12, when we are talking about the 8 vertex is adjacent vertex of this one is 2, 6, 7, and all are already visited. Then no need to relax any vertex. You can move further and just remove the 8 from the priority queue. Now this one is your priority queue and no updation is there. In case of 3 and 4, 3 is containing the minimum weight because it's containing the 16 weight. Now check for the other vertices. 4 is currently at the 19 weight. When you are adding this value, that is what? 16 plus 6, that is what? 22. 22 is greater than 19, then no need to relax the weight of vertex 4. Just remove this value and the value will get same. And now the last value is what? 4. All the vertices are already visited, then no need to change the value. This will get the final value. And here, the parent node will also get updated. If you want to check for a particular path, from which path you will get this minimum weight, you can go for the pi value. Just suppose, if you want to check that how to reach from 0 to node 4 with weight 90. Yes, it's saying that like this. There's 0 to 4. You are having the shortest path of cost 19. How to reach there? Just go for the pi value. Here, you can see that the 4, from 4, for reaching the 4, you are accessing the node 5. It means 4, you are getting the value. You are getting the 4 value from where? From 5. Go for the 5. What is the parent value of 5? You are reaching at 5 from 2. Again, go for the 2. And you are reaching from what? From 1. And in case of 1, you are reaching from 0. And 0 is the vertex starting source node. So this is the path from 0 to 4 in which you are getting the cost, minimum cost, that is 90. That is the usefulness of your parent array. This is also maintaining the previous path from where you are reaching at this particular location by using the shortest path, by getting the shortest path. I think this is clear to everyone how to use this Dijkastra algorithm to get the single source shortest path. These are the references. Thank you very much.